Good afternoon. Today we are doing trigonometry for a grade 12 learner. We're starting from the beginning. So with trigonometry, the first thing you must remember or you must know is you've got a diagram which has 4 quadrants, which actually use the shortcut cast, which is then for cos, and then all functions, sine and tan. So in the first quadrant, you've got all functions are positive, where you've got okay, the diagram is this is 0 degrees, that's 90, that is 180 degrees, this is 270, then also 360 there. So in the first quadrant, you've got your 90 minus theta, 90 minus the angle theta, and on the second quadrant, you've got 180 minus angle theta. So anything that is this side is actually 180 minus angle theta, or 90 plus theta. We are going anti-clockwise with this. So then the third quadrant, where actually the 10 is positive, you've got 180 plus theta, or 270 minus angle theta. Then we've got the fourth quadrant where the cos is actually positive. Here we've got a 360 minus theta, or 270 plus theta. And then again, you've got in the third quadrant, in the fourth quadrant, you've got 0. This is 0 minus theta, which gives you actually just a negative angle or negative theta, because you have 0 minus and this side we know is 0 plus, or actually 90 plus. So this side is 360 minus theta, or 0 minus theta, which is giving you a negative theta. Then there are a couple of rules that they are given to us, or you need to know. In case they're not provided in your formula sheet, you need to know them. So in the, this is just a summary of what I said now. So in the second quadrant, which is this one, we've got our sign is positive. So sine 180 minus theta, it gives you a positive sign because sine is in that quadrant. And anything else will be a negative because they don't belong in this quadrant. So only sine is positive in this quadrant, the same as tan is positive in the third quadrant, cos is positive in the fourth quadrant, then everything else is positive in the first quadrant. So in the second quadrant, sine 180 minus theta, we've got 180 minus theta in the second quadrant. So sine 180 minus theta is the positive sine theta. Cos 180 minus theta is a negative cos theta. Tan 180 minus theta is a negative tan theta. Then on the third quadrant is here where we've got a 10, which is a positive. Anything else is negative. And our angles is 180 plus theta, or 270 plus theta. Then our general formulas for this, so in the third quadrant, tan 180 plus theta is a positive tan. Sine 180 plus theta is a negative sine theta. Cos 180 plus theta is a negative cos theta. Then fourth quadrant. So we go into the fourth quadrant. Fourth quadrant is here where a cos is positive and the angle is cos 360 minus theta, or actually cos, or the angle is negative theta, or 0 minus theta. So then in that quadrant, a cos 360 minus theta, it gives you a positive cos theta. Sine 360 minus theta, it gives you negative sine theta. Tan 360 minus theta, it gives you negative tan theta. And which is the same as when you are given a cos negative theta. Cos is positive because it is in the fourth quadrant. So cos negative theta is a positive cos theta. Anything else is a negative. Sine negative theta is a negative sine theta. Tan negative theta is a negative tan theta. Then in the first quadrant, everything we said is positive. But with the our side, when you've got a 90 degrees, it changes the function. So sine 90 minus theta is a cos theta. You know, in our first quadrant, we've got 90 minus theta. So here we are. Sine 90 minus theta is a positive cos theta. Cos 90 minus theta is a positive sine theta. Just remember, with the 90 degrees, it swaps the angles. It swaps the functions. So cos 90 minus theta is a sine theta. Tan 90 minus theta is a positive cot theta. Then, if we go back into the second quadrant now, at just dealing with the 90 issue. So we know in the second quadrant we've got, and initially we used 180 minus theta. Now, if we look at the angle 90 plus theta, so in this quadrant sine is positive, and remember, the function changes when you are using a 90 degrees angle. So let's come back. So sine 90 plus theta, it gives you a positive cos theta, because a sine is positive in the second quadrant. So sine 90 plus theta is a positive cos theta. Cos 90 plus theta is a negative sine theta, because only a sine is positive in that quadrant. So cos 90 plus theta is a negative sine theta. Tan 90 plus theta is a negative cot theta. So the same goes to the other angles, which is a sec, cosec 90 plus theta. It will give you a positive. Cosec is just an inverse of sine. It will give you a positive sec theta. And same as sec 90 plus theta, it will give you a negative cosec theta. And then cot 90 plus theta, it will give you a negative tan theta. So okay, yes, that's that. So that's the first part. It's quite a mouthful of equation. It's a lot. Then another scenario that is there is actually when you have a negative here. So if they decide to move the angles, because normally it's actually anti-clockwise the way we are moving now, but now if they decide to move the angle in the clockwise direction, so if you're moving the angle in the clockwise direction, actually you are moving now in the negative, unlike when we were going this way. When you were going this way, here we like 90 minus theta, in this side 90 plus theta, or 180 minus theta. When you get to this side, 180 plus theta. Now we are coming this way, so it's a negative. If you are here, it will be actually negative 360 minus theta, or 270, negative 270 plus theta if you are in this in the fourth quadrant. When we get to the third quadrant, it's a negative 180, because it's a clockwise that we're going opposite. That's why it's a negative 180. But this side is plus theta, so negative 180 plus theta. Or actually it was going to be negative 270 minus theta this side. So that's how it goes. Even if you go that way, it will apply the same principle. So then the summary of that is, when you've got 10, because it's in the third quadrant, 10 is positive in the third quadrant. So we start with 10. So 10 negative 180 plus theta is a positive tan. Sine negative 180 plus theta is a negative sine theta. Cos negative 180 plus theta is a negative cos theta. So let's move to other rules. So you need to remember those rules. So the next rule that we're going to look at is actually determining is actually applicable to Pythagoras theorem. So in a Pythagoras, you've got a triangle. It's actually a 90-degree triangle, where you've got the opposite side and the adjacent side and the hypotenuse side. So from here, the equation, a sine theta, sine of that angle, sine is opposite over hypotenuse, so which is y over r, opposite over hypotenuse. Cos is a adjacent over hypotenuse, which is x over r. Tan is a opposite over adjacent, which is y over x. So, and the Pythagoras theorem is saying the hypotenuse side is equals to the square of the hypotenuse side is equals to the square sum of the square of the opposite plus the square of the adjacent side. So r squared is equals to x squared plus y. So then the other info that we need to know is actually the given angles. Like you need to know sine 30 degrees, you need to know sine 45 degrees, sine 60 degrees. So without using a calculator. So how you get to this, or how you must memorize it or have it in mind, you throw your axis here, which you've got y-axis and a x-axis and a y-axis. Then you give it your angle is 0, is 90, is 180, 270. Then we know from here approximately 30 degrees. So we're looking for angle 30 degrees, 45 and 60 degrees. So you just draw your arc there. Then how you get the values. So it's just a given info. It's not something that you're supposed to come up with. That's how they gave us. So from here, the rule is when you're calculating, so from the y-axis, this is y-axis, this is x-axis. So your x-intercept, for your x-intercept, you actually give your arcs the numbers. So you count from 0, you give it 0, the first one, going clockwise direction. So 0, you give it 1, you give the next one 2, you give the next one 3, the next one 4. Then to get the y values, you do the opposite. You give this one 0, you give the next one 1, you give it 2, you give it 3, you give it 4. Then they say you must just put square root all of them. Then those will be your coordinates for the y, x and y for that. And then it's also given that the r is always r is given as a value of 2. So that will be your r. So now you've got that. So now let's go and draw our triangles, because you've got 30, you've got 45, the next one is 60. It's not that visible. So for 30, we've got coordinates square root 3, square root 1. For 45, we've got square root 2, square root 2. For 60, we've got square root 1, square root 3. We're interested in this triangle, so we're not going to go to 90 degrees. We're not going to go to 0 degrees. So let's draw a triangle. So we've got the first one, triangle that has 30 degrees and 60 degrees. The other one, 45, 45. So from our given coordinates, let's start with 30 degrees. 30 degrees, so our x value is square root 3, our y value is square root 1. So x is square root 3, y is square root 1, which is actually 1. And then r is given as 2. 45, so we go to angle 45. Angle 45, we've got root 2 and root 2. So which x value is square root 2, y value is square root 2. So just take this as like an axis. This is the x and these are the y values. So, okay, that is that. Then even with 60, you can confirm with the 60. On 60, here are the values for 60. 60, we've got square root 1 as a x value, square root 3 as a y value. So 60, we've got y value, square root, where's y value? Okay, leave it that way. I'm going to confuse you now, but it's fine. So we've determined this triangle using the 30. And then we've determined that one using 45. What I'm trying to say now will come in just in a moment. So now we do a table, determine our sine 30. These are constant values that you know. So sine 30, what is the value of sine 30? We go to this triangle. Sine 30, a sine is opposite over hypotenuse, which is 1 over 2. So sine 30 will be 1 over 2. And then sine 45. So we've got 30, 45, and 60. Sine 45, there is 45 opposite over hypotenuse, so which is root 2 over 2. There is root 2 over 2. Sine 60, this is sine 60. Opposite over hypotenuse, root 3 over 2. Now we go to cos. Cos 30. Cos is adjacent over hypotenuse, so cos 30 adjacent over hypotenuse, and then which is root 3 over 2. Cos 45, adjacent over hypotenuse, root 2 over 2. And then sine, cos 60. Cos 60, here's 60. Adjacent over hypotenuse, 1 over 2. Then we go to 10. 1030. 1030 is opposite over adjacent, 1 over root 3. 1045, opposite over adjacent, root 2 over root 2, which will give us 1. And then 1060, root 3 over 1. So that's that. So you actually need to know this. You need to have this information. So the best thing when you write an exam or a test, first thing is to put all this given information down. If it's not given to you, try to remember and put them down so that when you start doing calculations, you just come back and take the values, plug them in those equations that are given in a question. So then we continue with the rules. Another rule, given rule is sine squared theta plus cos squared theta is equals to 1, or sine squared theta is 1 minus cos squared theta, or cos squared theta is 1 minus sine squared theta. This is a given rule that you later on in the equation you need to actually have your problem, try to rewrite it in this way or in that way or in that way, depending on what you're trying to achieve. But when you are solving those complex sums, you need to remember these rules. The other rule, tan theta is given as sine theta over cos theta. Then the other point that you need to remember, I put it down here. Note, adding or subtracting 360 degrees does not change the value of a trigonometric ratio. So this is what it means. If you come across where they've got sine, either sine theta plus or minus 360 degrees, is going to remain positive. It's not going to change the value of that trigonometric ratio. So sine theta plus 360 degrees, it remains sine theta. Cos theta plus or minus 360, it remains positive theta. Tan theta plus or minus 360 degrees, it remains tan theta. So just bear in mind, actually, you're starting with the angle. It's not everything else was actually this minus theta, or it was 360 plus or minus theta. Then there, it depends on those quadrants. But here, when you come across an angle where they are adding a 360, it does not change anything. It remains as that function. So sine theta of sine theta plus or minus 360 is a positive sine theta. Cos theta plus or minus 360 is a positive cos theta. Tan theta plus or minus 360 is a tan theta. So that is a lot of rules, but yeah, you have to come back every now and then when you solve your problem to come and get this given information and plug it back in your problem that you're solving. Then it makes it easy. Let's do examples now. Our first example, they say prove that the left-hand side is equal to the right-hand side. So left-hand side, we've got sine theta into 1 plus cos theta over 1 minus cos squared theta plus tan theta. Prove that is equals to 1 plus cos theta sine theta. So let's start. Our left-hand side is equals to sine theta into 1 plus cos theta over 1 minus cos squared theta plus tan theta. So then okay, so we've got sine theta 1 plus cos squared theta. Then remember the rule that I just finished with now. It was sine squared theta plus cos squared theta is equals to 1, or sine squared theta is equals to 1 minus cos squared theta. So we are trying to have common functions here. So we've got a sine theta. So you see this is actually sine squared theta, which is gonna look like the sine at the top. So this might take us somewhere. So we've got sine squared theta plus, and a tan, we can write a tan in terms of sine and cos, because our equation here has got sine and cos. So tan theta from the rules also is given as sine theta over cos theta. So sine squared theta and sine theta and sine squared theta, we can actually, this goes into this side by sine theta. So now we are left with 1 plus cos theta over sine theta plus cos theta, plus sine theta over cos theta. Then we can sum this, which we're gonna have cos sine theta cos theta. Sine theta into this goes into cos theta, so we've got cos theta multiplied by 1 plus cos theta plus cos theta into this goes into sine theta multiplied by sine theta. So we can remove the brackets. Cos theta plus cos squared theta, okay, plus sine squared theta all over sine theta cos theta. Already, can you see this? This is equals to 1. Remember, sine squared theta plus cos squared theta. You can just move it around, but it is equals to 1. So this value is 1. Therefore, we've got cos theta plus 1 over sine theta cos theta, which is actually 1 plus cos theta over sine theta cos theta, which is equals to the right hand side, which they were asking us to prove. So there you have it. So you see, we applied those two rules. There's number 1, which is 1, and also in the beginning we applied it here and make it a sine theta, and also the tan rule, we replace tan as that. So all those rules you learned about, they're applicable everywhere, all of them. Let's move to example number 2. They are asking us determine cos theta cos 60 degrees if you are given this diagram. So this diagram, you see they're giving you x is minus 2. So we've got minus 2 this side, and y is 8. So y is 8 and x is minus 2. So, and then we can get cos theta and cos 60 degrees. Cos 60 degrees, we can get it from here, the table we did. Cos 60 is half. So already we know cos 60 degrees is half. And then cos theta here is, a cos is adjacent over hypotenuse. So let's get hypotenuse. We don't know r. We know adjacent, we know hypotenuse. So let's get r. So we've got x squared plus y squared is equal to r squared. So x is negative 2 squared plus 8 squared is equal to r squared. We've got 4 plus 8 by 8. 64 equals to r squared. 68 is equal to r squared. Then if we square root this, 68 is actually 17 by 4, which is r squared. So r is actually square root of 17 by square root of 4, which is 2 root 17 is equals to r. Therefore our cos theta, you know, is x over r. X we already given is minus 2. R is root 2 over 17. So 2 will cancel 2. Then we are left with negative 1 over root 17. I hope I didn't miss anything. So then now we go back to the equation. The equation was saying cos theta, cos 60 degrees. Cos theta is negative 1 over root 17 multiplied by cos 60, we said is half. Therefore, the answer is negative 1 over 2 square root of 17. So that is that. Let's do last example. The last example, they say solve this. Sine 315 degrees cos negative 315 sine 210 degrees over 10 225. So you can try to rewrite this in terms of the angles 45, 60, 30. Then you'll be able to get because you need to solve this without using a calculator. So you can't by head just go straight from here and get the answer. So we're gonna write it like this. So we've got sine 315 is actually 360 minus 45. You see where I'm going? So I'm gonna end up with a function of 45. Then cos is cos negative 315. 315 is also 360 minus 45. And then sine 210. 210 is 180 plus 30. Sine 180 plus 30 degrees. Then it's all over 10 to 25. 10 to 25 is 180 plus 45. Right. So remember the quadrants. So 360 minus 45 is in the fourth quadrant. In the fourth quadrant only a cos is positive. And let's go back in the quadrants. So 360 minus 45 minus theta is in the fourth quadrant, and only a cos is positive on that side. So now, therefore, here we're going to have sine 360 minus 45 is a negative sine 45 because sine is not in the fourth quadrant. Multiplied by cos negative 360 minus 45. Remember, 360 minus 45, cos 360 minus an angle is the same as actually cos negative of that angle. So this is the same as actually cos negative 45. Then, which is, it's a positive. Remember, cos negative theta is a cos theta. And then sine negative theta is a negative sine theta because sine is not in the fourth quadrant. So here we're going to have a positive cos 45 degrees multiplied by sine 180 plus 30. 180 plus theta is in the second quadrant. No, it's in the third quadrant. Let's see, 180 plus theta is in the fourth quadrant. Somebody's doing something illegal. So 180 plus theta is in the third quadrant where tan is positive. Okay, let's go back. So sine 180 plus is going to give us a negative sine 30 degrees. And it's all over. Tan 180 plus is a positive. It's positive 10 45 degrees. So when we go, we have negative sine 45 degrees by cos 45 degrees by negative sine 30 degrees over tan is sine 45 over cos 45 degrees. Right. Then we can bring this to that other side. We've got negative sine 45 cos 45 negative sine 30 multiplied by, when you bring this one this side, you actually swap the ratio. So cos is going to come at the top and sine is going to come at the bottom. Now this sine cancels that sine 45. I hope what I'm doing is correct. So now we are left with negative and negative. The negative can fall away. Now we are left with cos 45 by sine 30 by cos 45. Now let's go and get the values of these numbers. Cos 45 and sine 30. Cos 45 is root 2 over 2. Root 2 over 2. Another cos 45 is square root 2 over 2. Then sine 30. Sine 30 is half. Sine 30 is 1 over 2. Then root 2 by root 2 is actually 2. And then 2 by 2 by 2 is 8. We have 1 over, goes into 4. 1 over 4. So that is that. Hope it makes sense. But this is not the end of trigonometry. It still goes further. You're going to have double angles. You're going to have sum of the angles. So that's how far we can get. Thank you very much. Hope it makes sense.